observers, as well as local operations to access the vacuum state correlations in their local regions. So it's not quite our quantum communication in full yet, a nearly instantaneous communication, since it still requires a classical channel. Now, a version of this is already used to teleport information between two systems, and we've reviewed this in our last session, the quantum teleportation methodology. And we reviewed this in the traversable wormhole teleportation protocol experiment. And the recording for that is available in the Members Hub on the Resonance Science Foundation website. However, there are other potential quantum teleportation case scenarios. This was just information, teleporting a quantum state of a system of qubits from one quantum system to a secondary quantum system. But it should, in principle, be possible to teleport other physical quantities, especially by utilizing the universal entanglement of the field, such as teleportation of energy between two systems or observers via the vacuum state entanglement of their local regions. And that is what is called quantum energy teleportation. So consider, for example, two observers who, Alice and Bob, who want to teleport a quantity of energy between themselves using the entanglement nexus of quantum vacuum fluctuations. As we have discussed, the field possesses 0-point fluctuations, but as well, there's non-trivial correlations of the field induced by vacuum state entanglement. So if Alice obtains information about a local fluctuation around her through a measurement, she simultaneously obtains some information about a local fluctuation around Bob via the correlation. Although the average value of the vacuum energy density in Bob's region remains 0 after Alice's measurement, Bob's local field in the post-measurement state can carry a negative energy density depending on Alice's measurement result. When the result indicates the positive energy case, Alice sends Bob's a message via classical communication channel. So this is one reason why this isn't going to be instantaneous, because it's still obeying the structure of causality and the relativity of simultaneity, because she has to send this no faster than the speed of light, a classical communication channel. But she takes a measurement, in doing so, injects energy into the system. Now, her local vacuum oscillations now have a positive energy density. She relays that state via message to Bob. Now, Bob, timing it just right, can access via a local operation the vacuum fluctuations in his local vicinity and extract energy from the field. And in a sense, in a way, this would be akin to Alice having teleported the energy to Bob, because she doesn't send the energy via any kind of classical channel. She injects the energy into the vacuum energy fluctuations around her, tells Bob about it. Bob times it so that he can retrieve energy from his local vacuum fluctuations because the experimental setup here, it has very much to do with the timing of these operations, the classical communication, where Alice communicates her measurement that injected energy into the local quantum vacuum fluctuations of her vicinity. She obtains a positive energy density. She communicates that to Bob in such a way and it's timed in such a way that Bob can perform a local operation, kind of like another measurement, in which he can extract energy from the quantum vacuum in his local vicinity. So some key considerations in this is that this isn't exactly harnessing quantum vacuum energy in the fullest capacity, in the truest sense, because there's a balanced conservation of energy in this sense. Bob is only extracting an amount of energy that is commensurate with what Alice injected into the vacuum energy density. And he's able to do so because of the spatial correlation, the quantum entanglement between the two regions. It's necessarily occurring at or below the speed of light. So this isn't a instantaneous signaling or teleportation scheme yet. There's these first initial most experiments that have successfully demonstrated this proposal. The proposal comes from Masahiro Ota, and he's just done a lot of phenomenal work with better understanding the nature of the quantum vacuum and how to harness potentially energy from the quantum vacuum. So it's more than 15 years ago that Masahiro Hota developed and proposed the protocol for teleporting energy via that scheme that we just looked at. And he has many ideas that I would love to quote, but one that I definitely need to share from one of his publications, one of his papers: quantum fields and vacuum states carry an infinite amount of quantum entanglement. And so this goes back to the idea of entanglement harvesting, entanglement farming, or even how two systems, maybe even two people, two organisms separated in space can have in a connection, in exchange, without the kind of normal direct physical interactions via this infinite amount of quantum entanglement, the entanglement nexus of the quantum vacuum. So in the experiment, it was actually done using organic polymers, molecules. And one of the things that had to be overcome in order to do this quantum energy teleportation protocol was this restriction called strong local passivity, SLP. And basically what this restriction says is that if you have a system of connected particles, these are correlated to some degree, you know, whether it's a mixed state or a pure state, but there is correlation between these. And if they're in the ground state, they are fully quantum entangled. The ground state is another term for the vacuum state, because the vacuum has infinite quantum entanglement. Now, if you were to inject energy, so that's Alice's measurement, right? If you were to inject energy into the system, you wouldn't be able to tap it or access it from one of the subunits of that system, because the energy will be distributed via all of them nearly instantly and equally, because they're quantum entangled. So energy that goes to one of the subunits is going to be almost instantly distributed among all of them. And so you can't draw energy from one of the subunits. So if one of these was representing Alice and the other was representing Bob, you couldn't achieve that quantum energy teleportation because the energy that goes in with Alice's measurement, the energy that she would inject into her, the vacuum state around her would be instantly distributed through the entire system. But the researchers came up with a mechanism for breaking this strong local passivity with what are called local operations and quantum classical communication. So timing this local measurement just right, communicating that outcome to one of the subunits, they can then perform a secondary measurement that draws energy from the vacuum state quantum entanglement. Yeah, so the main hurdle to overcome with actually being able to do this experimentally and demonstrate it is that any local action taken on a single subunit to extract energy will result in energy spreading through the entanglement network, merely raising the total energy of the system. However, there is a way to activate entangled ground states of a multi-type quantum system in such a way that energy injected into the system can be extracted from a single distal subsystem via the local vacuum energy density and the intrinsic entanglement of the vacuum state. And that is something that was done by, led by Eduardo Martinez. And this is a researcher that has done, like Jota, some really phenomenal, remarkable work with, moving past the idea of are the quantum vacuum oscillations theoretical